Hello, in this video we're going to learn about factoring polynomials. In the past couple videos we've been multiplying polynomials or monomials and polynomials, and it looked kind of like this. So we got 7x times x plus 2, and we were able to multiply them together one by one like this. 7x times x is 7x squared, and then 2 times 7x would be plus 14x. And so we would know that our answer is 7x squared plus 14x. That's multiplying. Now factoring is the opposite of multiplying. In factoring, we're given the 7x squared plus 14x, and we're supposed to figure out what two things were multiplied together to get that. Okay, so we're going to work backwards from what we learned a couple of videos ago. So the question is, how do we do that? Well, what we do is we split up each term into its prime factors. So 7 times x are the prime factors of 7x squared. And then the prime factors of 14x are 2 and 7 and x. Then you figure out what they have in common. So they both have a 7 and they both have an x. Okay. And so if you factor out 7x, that's what goes out here. And then what's left over, let's see, what I've underlined here, goes up top. So the x from this and the plus 2 from that. And so you can see we end up with the same thing. So let's try it again. 5x plus 10. This one's not too bad. So if you were to put this in a box, oops, let's try that again. I'll make my box, and I'll put 5x plus 10 in it. And we need to figure out what goes on the outside. So I'm going to get my factors here. So 5x, that's easy, it's 5 and x. And 10 is 2 and 5. So in common, they have 5. And so that's the number we're going to put out front, so 5. And then the number that goes on top, or the numbers, is the remaining stuff here. So we have an x and a plus 2. Now the easy way to figure out if you got the answer correct is by doing the multiplication. So 5 times x, 5 times 2 to check it. And so now we know our answer is 5 times x plus 2. That's our factored answer. Notice it would have been in the beginning a couple videos ago. Now it's the answer. Whereas we're getting the answer from a couple videos ago and making it the beginning. So it's the opposite. Now let's try this one. So we have 9a cubed. This time we have a minus in there. Not a problem. So we have 9a cubed and a minus 27a squared. Same thing, we're going to get the prime factorization. So 9 is made of a 3 and a 3. And then we have 3 a's. And then negative 27, I'm going to go ahead and put a minus here. 27 is made up of 3 times 3 times 3. Then we have 2 a's. So in common, they have 2 3's and 2 a's. And then not in common is an a and a minus 3. So on the left side, I'm going to push the accordion back again on these, squish them together, and get 9a squared for the outside or the left, and then the remaining stuff, the a minus 3, goes on top. And so I think the answer is 9a squared times a minus 3. And to check it, we can just do the multiplication. So 9a cubed minus 27a squared. We're good to go. This is our final answer. Okay, and some of them get a little more challenging and they have more terms in them. And you don't actually have to use the box method, but I find it nice in the beginning to get everything figured out, so we'll keep doing it for a while. So I'm going to make this a little wider since we have 3 terms. So we have 22k 6t5 plus 110k 4t6, so that 4 is kind of hard to read, and then minus 55k7t5. Okay. Now there's a bunch of letters in this one, so rather than writing them all out, we're going to try something else. We're going to take a little shortcut here. So 22 is made up of 2 and 11, and then we just have k6t5. And then 110 is made up of, well, 11 times 10, but then we have 10 is 2 and 5. So 2, 5, 11, and then k4 t6. Okay, and then the last one is made up of I'll put a minus here, I'll put a plus here to show the separation. So minus, we have a 5 and an 11, and then k7t5. Okay, so number-wise, they all have not a 2. It looks like they all have an 11 in common. Now the letters, instead of writing them all out, we can tell if there's 6 k's here, and 4 here, and 7 here, they all have 4 in common. So I'll just, since that looks a little scribbled, I'll write it here. K, geez, I can't seem to get my 4's down. K4, there we go. So they all have 4 K's. And they all have, there's 5 T's, 6 T's, and 5. So they all have 5 T's as well. So let's write that down. 5T. Okay, so on the left, we're going to write 11 K4T5. Okay, so what's left is going to be the numbers from each one, but also some letters. So let's just take care of the numbers first. So we're going to have a 2 here and 10 here, that's plus, and then a minus 5. Now letter-wise, if we factored out 4 K's, there's still 2 left here. So we have 2 K's. And if we factored out 5 T's, there's none left. So we're done with that term. This middle term, if we factored out 4 K's, that's all of the K's. So we're done with that. But we only factored out 5 T's, and there's one more left. So I'm going to put a T here. And okay, we factored out 4 K's from here, so there's 3 of them left. And then we factored out 5 T's, which is all there were, so we're done. Okay, so now I'm going to write down my answer down here, which is 11K4T5 times 2K squared plus 10T minus 5K to the third. And I'll do some quick calculation to see if I got that right. 11 times 2 is 22. Then I have 6 K's and 5 T's. That's good. 11 times 10 is 110. 4 K's and 6 T's. And then I have 11 times negative 5 is negative 55 with 3 and 4. So 7 K's and 5 T's. So this is the correct answer. Alright, now we're going to get to one that's a tad trickier here. So, and what makes it tricky is these plus signs here. This is really a binomial as it's written right now with 2 terms. Here's one term and here's another. It looks like it might have like 1, 2, 3, 4 or 6 terms in it. But the fact that this is in parentheses and being multiplied, this can be thought of as a term. You could also simplify it and make it more terms, but that's not the point of what we're getting to right now, because we are factoring. I'll write it up here so we remember. We're factoring. So if we were to take the prime factors of this, we would say, well, there's a 3 and there's an x. And here's the weird part. We're going to call the whole x plus 2 a prime factor. And over on this right side, we have a 5 and a x plus 2, and an x plus 2 is a factor. Put my little dot there. So in common, they have x plus 2. So that's what we would factor out, x plus 2. Oops, let me do that in a different color. And then what's left over would be the 3x and the minus 5. So we write 3x minus 5. So this is one of the ways that you can factor to get two binomials. Notice in all these previous examples we got a monomial and a polynomial, a monomial and a polynomial, a monomial and a polynomial. In this last one we get two binomials. So this won't really be important until we get into the 8th grade, but I just wanted to show you that. Alright, thanks for watching the video.